In the peaceful darkness of a hypothetical night, imagine looking up at the stars above Manhattan's glittering skyline, unaware that hurtling toward Earth at an unimaginable speed is 3I Atlas, a mysterious interstellar visitor that some scientists believe might be artificial, now on a collision course with one of humanity's greatest urban centers. Tonight, as you settle into this gentle exploration of cosmic catastrophe, we'll journey through the science of what would happen if this enigmatic object, traveling at 58 kilometers per second from the depths of interstellar space, were to impact the heart of New York City. Before we embark on this thought-provoking journey through physics and human resilience, please take a moment to subscribe to our channel and ring that notification bell. Your support helps us explore these fascinating scientific scenarios with care and accuracy. Picture the serene moments before impact as 3I Atlas, an object that has traveled across the cosmic void for potentially thousands of years, enters Earth's atmosphere above the North Atlantic. Consider the unique composition of this cosmic wanderer as it begins its final approach. Data from the Webb Space Telescope and is composed primarily of carbon dioxide, CO2, 87% by mass, carbon monoxide, CO, 9%, water, H2O, most of the remaining 4%, and traces of cyanide, CN, as well as nickel without iron, as found in the industrial production. This unusual chemical makeup, unlike anything naturally found in our solar system, suggests that 3I Atlas carries within its structure the frozen history of alien star systems and interstellar chemistry processes. Drift deeper into the physics of this approaching catastrophe as 3I Atlas encounters Earth's upper atmosphere at a velocity of 58 kilometers per second, over 130,000 miles per hour. At this tremendous speed, the object begins experiencing forces no earthly material has ever endured. The tenuous gases of the upper atmosphere, normally invisible and inconsequential, become like a solid wall of resistance to an object moving at such extreme velocity. Imagine the sequence of events as 3I Atlas begins its final plunge toward Manhattan. The friction between the object and atmospheric molecules instantly heats its surface to temperatures exceeding those found in stellar cores. The frozen carbon dioxide and carbon monoxide that comprise most of its mass begin sublimating explosively, creating a brilliant fireball visible from hundreds of miles away. This is not the gentle entry of a spacecraft designed for atmospheric passage, but the violent collision between an interstellar interloper and Earth's protective gaseous envelope. As 3I Atlas descends through the stratosphere and mesosphere, the increasing atmospheric density creates ever greater resistance. The object's exotic materials, nickel without iron, trace cyanides, and organic compounds formed in the frigid depths of space, begin reacting with Earth's oxygen-rich atmosphere in ways that have never occurred naturally on our planet. These chemical reactions release additional energy, adding to the already tremendous heat generated by friction. Picture the visual spectacle as witnessed from New York City's streets in these final moments before impact. Citizens looking up would see what appears to be a second sun blazing across the sky, brighter than Venus at its peak, casting sharp shadows even in broad daylight. The object's trail would stretch across the heavens like a cosmic sword, leaving behind a persistent contrail of exotic gases and vaporized debris from its own substance. The acoustic signature of 3I Atlas's approach would be equally remarkable. The sonic boom generated by an object of this size moving at hypersonic speeds would shatter windows across a radius of dozens of miles. But this would be merely the prelude to the main event. The impact itself would generate sound waves of such intensity that they would be felt as physical pressure waves by anyone within hundreds of miles of ground zero. Consider the brief moments as 3I Atlas passes through the troposphere, Earth's lowest atmospheric layer where weather occurs and commercial aircraft fly. At this altitude, atmospheric density becomes significant enough to begin seriously affecting even an object of such tremendous mass and velocity. The increasing pressure and heat cause rapid ablation, the object literally burning away layer by layer as it sacrifices its own substance to the violence of atmospheric entry. Yet even as 3I Atlas loses mass to atmospheric ablation, its core remains intact, protected by the very material being stripped away from its surface. The carbon dioxide and carbon monoxide that sublimate and burn create a protective plasma sheath around the object is interior, allowing its dense core to survive the atmospheric passage largely unchanged. This phenomenon, known as the heat shield effect, ensures that a significant portion of the original object will reach Earth's surface. As the object approaches the final kilometers of its descent, passing over the Hudson River and the outer boroughs of New York City, the physics of hypersonic atmospheric entry reach their most extreme manifestation. The air in front of 3I Atlas becomes compressed to pressures exceeding those found at the bottom of Earth's deepest ocean trenches, while temperatures soar beyond the melting point of any terrestrial material. The electromagnetic effects of this atmospheric passage would be equally dramatic. The ionization of air molecules around 3I Atlas creates a temporary disruption in radio communications across the entire eastern seaboard. Satellite signals become garbled, cellular networks experience widespread outages, and electromagnetic pulses generated by the object's passage through Earth's magnetic field lines cause power fluctuations in electrical grids hundreds of miles from the impact zone. In these final seconds before impact, the curvature of 3I Atlas's trajectory becomes apparent to observers on the ground. The object, initially appearing as a bright star moving across the sky, now reveals itself as a massive, glowing projectile aimed directly at the heart of Manhattan. The psychological impact on witnesses would be profound. The realization that their city, their home, stands directly in the path of a cosmic bullet fired from the depths of interstellar space. But as 3I Atlas completes its final approach over the skyscrapers of Midtown Manhattan, the most extraordinary chapter in this cosmic story is about to begin. The moment when interstellar matter meets one of humanity's greatest urban achievements. In the fleeting instant before impact, imagine the surreal calm that settles over Central Park as 3I Atlas, now a blazing fireball nearly half a mile across, descends through the final 1,000 feet above Manhattan's skyline. The object's tremendous velocity, 58 kilometers per second, means that the entire sequence from atmospheric entry to ground impact unfolds in less than 2 minutes. Yet, within that brief time span, the physics of cosmic collision will reshape one of Earth's greatest cities forever. Picture the precise moment when 3I Atlas strikes the northern end of Central Park, near the Harlem Mere. The kinetic energy released in this instant dwarfs all human experience with explosive force. The flux detected by the Spherex Space Observatory at a wavelength of 1 micrometer from 3I Atlas on August 8 to 12, 2025, suggests an even larger nucleus with a diameter of 46 kilometers, as reported here. This implies that the mass of 3I Atlas is 1,000,000 times larger than that of the previous. Even using conservative estimates of the object's size and density, the energy released would equal hundreds of megatons of TNT, vastly exceeding any nuclear weapon ever detonated. The immediate effects of impact radiate outward from ground zero in concentric rings of destruction, each governed by different physical mechanisms. In the first microseconds, the collision between 3I Atlas and the Earth creates temperatures exceeding 10,000 degrees Celsius and pressures millions of times greater than atmospheric pressure. The bedrock of Manhattan, ancient schist and gneiss that has underlain the city for millions of years, instantly vaporizes in a sphere expanding outward at several kilometers per second. Consider the formation of the impact crater in the heart of New York City. The vaporization and excavation of Manhattan bedrock creates a cavity initially several kilometers across, extending deep into the Earth's crust. Unlike the gentle parks and carefully planned architecture that previously occupied this space, the crater represents a wound in the planet itself, a perfectly circular scar that will remain visible from space for geological ages. The excavated material, vaporized rock, soil, and the transformed substance of 3I Atlas itself erupts upward in a towering ejecta plume that reaches into the stratosphere. This material, heated to stellar temperatures and accelerated to hypersonic velocities, rains back down across hundreds of miles of the eastern seaboard as molten droplets and superheated fragments. Each piece of debris becomes a secondary source of destruction, igniting fires and causing localized impacts across an area stretching from Boston to Washington. D.C. drift deeper into the immediate aftermath as the primary shock wave expands outward from the impact site. This pressure wave, traveling through solid rock at speeds approaching 8 kilometers per second, carries enough energy to instantly collapse every building within a radius of several miles. The skyscrapers of Midtown Manhattan, architectural marvels that represent centuries of engineering advancement, crumble like sand castles before this cosmic tsunami of pure kinetic force. The iconic structures of New York City face destruction in a precisely ordered sequence, determined by their distance from ground zero. The Empire State Building, standing about 2 miles south of the impact site, experiences the full force of the underground shockwave approximately 15 seconds after impact. The building's steel framework, designed to flex in high winds and minor earthquakes, proves utterly inadequate against forces generated by interstellar collision. In a matter of seconds, this symbol of human architectural achievement collapses into rubble. Picture the fate of the subway system. New York's underground circulatory system that carries millions of passengers daily through tunnels carved from Manhattan's bedrock. The shock waves traveling through solid rock reach these tunnels almost instantaneously, causing catastrophic collapse across the entire network. The carefully engineered infrastructure that allows 8 million people to move efficiently through the city disappears in moments, crushed by geological forces unleashed from the depths of space. The atmospheric effects of the impact create a secondary wave of destruction that follows the underground shock. The explosion hurls billions of tons of vaporized rock and debris into the atmosphere, creating a pressure wave that travels outward through the air at supersonic speeds. This atmospheric blast, similar to the after the blast, 1287 square kilometers of forest were flattened, with 80,000 trees felled, clearing an area larger than London. Witnessed in the Tunguska event, but orders of magnitude more powerful, levels everything above ground within a radius of dozens of miles. Buildings beyond the immediate zone of underground destruction face a different but equally devastating fate. The atmospheric pressure wave, carrying winds exceeding 1,000 kilometers per hour, strips away facades, shatters windows, and topples structures with the force of an atomic-scale hurricane. Even reinforced concrete buildings designed to withstand earthquakes and terrorist attacks prove helpless against the cosmic forces unleashed by 3I Atlas. Consider the unique chemical effects of this interstellar impact. Unlike terrestrial meteorites composed of familiar rock and metal, 3I Atlas brings exotic chemistry from beyond our solar system. The new observations reveal a cloud of carbon dioxide, CO2, around 3I Atlas, corresponding to a mass loss rate of about 70 kilograms per second. The massive release of carbon dioxide, carbon monoxide, and trace cyanides creates a localized atmospheric disturbance unlike anything in Earth's geological record. The electromagnetic pulse generated by the impact affects electronic systems across the eastern United States. The collision between the object's ionized plasma and Earth's magnetic field creates electromagnetic waves that overload power grids, disable communications networks, and destroy unprotected electronic equipment. In an instant, the digital infrastructure that connects New York to the global economy ceases to function. Yet perhaps the most profound immediate effect lies in the psychological impact on witnesses who survived the initial destruction. Those fortunate enough to be beyond the immediate blast zone witnessed the transformation of one of humanity's greatest cities into a smoking crater in a matter of minutes. The psychological trauma of watching such rapid, total destruction would affect survivors for generations, fundamentally altering human perception of cosmic threats and urban vulnerability. The thermal pulse generated by the impact creates firestorms that rage across the metropolitan area for days following the collision. The radiant heat, comparable to standing near the surface of the sun, ignites everything combustible within dozens of miles. These fires, fed by broken gas lines and spreading through the debris of collapsed buildings, create a secondary disaster that extends the destruction far beyond the immediate impact zone. But as the immediate violence of cosmic collision subsides, an even more complex story begins to unfold. The beginning of New York's transformation from one of Earth's greatest cities into something entirely unprecedented. In the eerie silence that follows the cosmic violence, imagine the transformed landscape where Manhattan once stood. Now, a smoking crater nearly 3 miles across, filled with molten rock and the vaporized remains of one of humanity's greatest urban achievements. The immediate aftermath of 3I Atlas's impact represents not just the end of New York City as we know it, but the beginning of a complex chain of geological, atmospheric, and biological effects that will reshape the entire eastern seaboard for decades to come. Picture the view from space in the hours following impact, as satellites that survived the electromagnetic pulse begin transmitting images of the disaster zone, where Central Park once provided a green rectangle of tranquility amid the urban landscape. Now a perfectly circular crater glows with residual heat from the cosmic collision. The crater walls, composed of Manhattan's ancient bedrock transformed by temperatures and pressures beyond terrestrial experience, rise like the rim of a lunar impact site transplanted to Earth. Consider the fate of the surrounding boroughs in these critical first hours. Brooklyn, Queens, and the Bronx, areas that escaped the immediate vaporization zone, now face a different but equally challenging disaster. The atmospheric shockwave has leveled most buildings within a 20-mile radius, while the rain of superheated debris has ignited thousands of fires across the metropolitan area. Emergency services, already overwhelmed by the scale of destruction, struggle to respond as roads remain blocked by rubble and communication systems fail to function. The Hudson River and East River, Manhattan's liquid boundaries, begin filling the impact crater as water seeks its new lowest point. This influx creates a temporary inland sea where Midtown Manhattan once stood, but the water boils away almost instantly upon contact with the superheated crater walls. The steam rising from this process adds to the already massive atmospheric disturbance, creating localized weather patterns unlike anything in meteorological records. Drift deeper into the atmospheric consequences as the impact plume continues its ascent toward the stratosphere. Billions of tons of vaporized rock, mixed with the exotic chemistry of 3I Atlas, form a dust cloud that blocks sunlight across much of the eastern United States. This impact winter effect, similar to but more localized than global extinction events, begins affecting temperature and weather patterns within hours of the collision. The chemical composition of this atmospheric debris tells the story of interstellar chemistry mixing with terrestrial geology. Data from the Webb Space Telescope and is composed primarily of carbon dioxide, CO2, 87% by mass, carbon monoxide, CO, 9% water, H2O, most of the remaining 4%, and traces of cyanide, CN, as well as nickel without iron, creates an atmospheric cocktail never before experienced on Earth. The massive release of carbon dioxide temporarily alters local atmospheric composition, while trace cyanides pose long-term health risks for survivors in the affected region. Picture the geological instability triggered by the impact as seismic waves continue radiating outward through Earth's crust. The collision has essentially created an artificial earthquake measuring well above 9.0 on the Richter scale, with aftershocks continuing for weeks as the planet's crust adjusts to the sudden removal of billions of tons of material. Buildings as far away as Philadelphia and Boston, already damaged by the initial shockwave, face additional collapse as these secondary tremors shake already weakened foundations. The electromagnetic effects of the impact continue to cascade through technological systems across North America. The ionization of the upper atmosphere disrupts satellite communications, while ground-based electrical grids struggle with surges and failures caused by the geomagnetic disturbance. Modern society's dependence on electronic infrastructure becomes tragically apparent as transportation, communication, and financial systems experience widespread failure. Consider the immediate human toll as emergency response organizations attempt to assess the scope of the disaster. The transportation infrastructure that connects New York to the rest of the continent lies in ruins. Bridges that survived the initial impact face structural failure from ongoing seismic activity, while airports throughout the region remain closed due to debris-filled runways and damaged control systems. The economic arteries that make New York a global financial center have been severed, creating ripple effects throughout world markets that will persist for years. Picture the heroic efforts of survivors and emergency responders working in an environment unlike anything in human experience. Rescue workers equipped with radiation detectors and breathing apparatus navigate through a landscape of twisted steel and vaporized concrete, searching for survivors in the outer zones of destruction. The exotic chemistry released by 3I Atlas creates new hazards. Atmospheric concentrations of carbon monoxide and trace cyanides require specialized protective equipment that most emergency services lack. The thermal effects of the impact continue affecting the broader region as fires ignited by the initial heat pulse spread through debris and broken infrastructure. These conflagrations, fed by ruptured gas lines and aided by impact-generated winds, create firestorms reminiscent of those that followed the atomic bombings of World War II, but on a vastly larger scale. The smoke from these fires adds to the already massive atmospheric disturbance, further blocking sunlight and affecting air quality across the eastern seaboard. Wildlife throughout the region faces unprecedented challenges as natural habitats disappear overnight. Birds and migrating species experience disorientation from the electromagnetic effects, while terrestrial animals struggle to navigate through a transformed landscape. The impact has essentially created an ecological disaster zone where familiar ecosystems have been replaced by conditions more reminiscent of an alien planet than Earth. The psychological trauma experienced by survivors extends far beyond those directly affected by the impact. Television and internet images of Manhattan's transformation from iconic skyline to smoking crater affect viewers worldwide, fundamentally altering human perception of cosmic threats and urban vulnerability. The realization that a single object from interstellar space could eliminate one of Earth's greatest cities in minutes forces a complete reevaluation of humanity's place in the cosmos. International response begins mobilizing as the scope of the disaster becomes clear. Military and civilian assets from around the world prepare to assist with rescue operations, but the scale of destruction challenges conventional disaster response protocols. The loss of New York's port facilities, airports, and transportation infrastructure complicates efforts to deliver aid to survivors, while ongoing atmospheric and seismic effects make the disaster zone extremely dangerous for rescue operations. As the first day after impact draws to a close, the immediate emergency phase begins transitioning into a longer-term crisis that will reshape not just the geography of the eastern seaboard, but the course of human civilization itself. The crater that was once Manhattan glows with residual heat against the darkening sky, a cosmic wound that will serve as a permanent reminder of humanity's vulnerability to forces from the depths of space. But as we examine the longer-term consequences of this cosmic collision, the most profound changes may not be geological or atmospheric, but deeply human. In the gentle weeks and months following 3I Atlas's impact, imagine the subtle but profound ways that this cosmic collision begins reshaping Earth's environmental systems, creating changes that ripple outward like waves from the impact crater to affect global weather patterns, ocean currents, and atmospheric chemistry. The transformation extends far beyond the immediate destruction zone, demonstrating how a single object from interstellar space can alter planetary systems that evolved over billions of years. Picture the atmospheric aftermath as the massive dust cloud continues its journey through Earth's upper atmosphere. Unlike volcanic eruptions that inject primarily water vapor and sulfur compounds into the stratosphere, the 3I Atlas impact has introduced exotic chemistry from beyond our solar system into Earth's atmospheric circulation. The dust cloud, enriched with vaporized carbon dioxide and trace compounds never before present in terrestrial atmosphere, begins affecting global temperature and precipitation patterns. The impact winter phenomenon manifests differently than similar events in Earth's geological history. After the blast, 1287 square kilometers of forest were flattened, with 80,000 trees felled, clearing an area larger than London. While the Tunguska event demonstrated how atmospheric explosions can affect local ecosystems, the 3I Atlas impact operates on a scale that influences planetary systems. The dust and debris ejected into the stratosphere create a partial solar filter that reduces global temperatures by several degrees, enough to affect growing seasons worldwide and alter precipitation patterns across continents. Consider the unique chemistry now circulating through Earth's atmosphere. The massive release of carbon dioxide from 3I Atlas's composition temporarily increases atmospheric CO2 concentrations in the northern hemisphere, creating localized greenhouse effects that partially counteract the cooling from dust and debris. This creates complex regional climate variations, some areas experiencing unseasonable warming, while others face prolonged cooling, disrupting agricultural cycles and natural ecosystems across the globe. Drift deeper into the oceanic consequences as the impact's effects propagate through marine systems. The Atlantic Ocean, receiving runoff from the impact crater and surrounding areas, begins experiencing chemical changes as exotic compounds from 3I Atlas dissolve into seawater. Marine biologists detect unusual pH variations and the presence of trace metals and organic compounds that have no terrestrial analog, creating new challenges for ocean life adapted to Earth's natural chemistry. The seismic effects of the impact continue reverberating through Earth's geological systems months after the initial collision. The sudden removal of billions of tons of material from Manhattan creates ongoing crustal adjustments that manifest as unusual earthquake activity along the eastern seaboard. These secondary effects damage infrastructure already weakened by the initial impact, complicating recovery efforts and creating new geological hazards in areas previously considered seismically stable. Picture the electromagnetic effects as they continue disrupting Earth's technological infrastructure. The ionization caused by 3I Atlas's atmospheric passage has created long-lasting changes to the upper atmosphere's electrical properties. Radio communications experience persistent interference. Satellite operations require constant adjustments for atmospheric effects, and power grids throughout North America struggle with ongoing electromagnetic fluctuations that make normal operations difficult. The biological consequences of the impact extend far beyond the immediate destruction zone. The combination of chemical contamination, electromagnetic interference, and climatic disruption creates stress on ecosystems across multiple continents. Migratory species face navigation difficulties due to altered magnetic field patterns, while plant communities struggle with changed light conditions and atmospheric chemistry. The impact has essentially created a biological experiment on a planetary scale, introducing variables that evolution never prepared terrestrial life to handle. Consider the agricultural implications as the first growing season after impact unfolds. The dust cloud's effect on solar radiation, combined with altered precipitation patterns, creates crop failures across much of North America and Europe. The global food system, already stressed by population growth and climate change, faces additional pressure from this cosmic disruption. Emergency food reserves become critical as agricultural regions struggle to adapt to the new environmental conditions. The hydrological cycle experiences profound disruptions as the atmospheric chemistry changes affect cloud formation and precipitation patterns. The exotic compounds released by 3I Atlas interact with water vapor in ways that alter rainfall distribution, creating droughts in some regions while causing unprecedented flooding in others. River systems throughout the eastern United States show chemical signatures of the impact, as contaminated groundwater slowly makes its way into surface waters. Forest ecosystems across the impacted region face a complex set of challenges that extend far beyond the initial thermal pulse and shockwave damage. The combination of reduced sunlight, altered atmospheric chemistry, and ongoing seismic activity creates conditions unlike anything in their evolutionary history. Many tree species show signs of stress from the exotic atmospheric chemistry, while soil contamination from impact debris affects root systems and nutrient absorption. Picture the marine ecosystems as they begin adapting to the new chemical environment. Fish populations in the North Atlantic show behavioral changes as they encounter water containing trace compounds from 3I Atlas. While most of these substances exist in concentrations too low to cause immediate toxicity, their long-term effects on marine food chains remain unknown. Scientists begin the first studies of how interstellar chemistry affects terrestrial biology, research with implications far beyond the immediate disaster. The polar ice caps begin showing subtle changes as the atmospheric dust cloud affects global heat distribution. While the overall cooling effect is modest, the altered atmospheric circulation patterns affect ice formation and melting cycles in ways that contribute to sea level variations worldwide. Climate scientists struggle to model these effects because Earth's climate models contain no parameters for interstellar chemical influences. Urban heat island effects in cities worldwide experience modifications as the atmospheric dust cloud alters the normal patterns of solar heating. Cities that previously experienced elevated temperatures due to concrete and asphalt absorption find their local climates moderated by the reduced solar radiation. These changes affect everything from energy consumption patterns to the behavior of urban wildlife populations. The atmospheric chemistry changes also affect the formation and behavior of Earth's protective ozone layer. The exotic compounds from 3I Atlas interact with stratospheric ozone in ways that create localized variations in UV protection. Some regions experience enhanced ozone formation, while others see temporary reductions, creating a patchwork of radiation exposure levels that affect both human health and ecosystem function. As the first anniversary of the impact approaches, environmental monitoring stations worldwide continue detecting subtle but persistent signatures of the cosmic collision. The event has essentially created a new baseline for Earth's environmental systems, one that includes chemistry and physics effects that originate from the depths of interstellar space rather than natural terrestrial processes. But perhaps the most profound environmental consequence lies not in the measurable physical changes, but in humanity's transformed relationship with the planet we call home. In the inspiring months and years following the cosmic catastrophe, imagine the remarkable demonstration of human resilience as survivors, and communities worldwide unite to rebuild not just the physical infrastructure destroyed by 3I Atlas, but to create something new and perhaps better adapted to the realities of living on a planet vulnerable to cosmic forces. The recovery becomes a testament to humanity's capacity to transform unimaginable tragedy into an opportunity for growth, innovation, and deeper understanding of our place in the cosmos. Picture the immediate human response in the days following the impact, as emergency services from around the world converge on the disaster zone. Canadian search and rescue teams work alongside Mexican disaster response units, while European emergency services coordinate with Asian relief organizations in an unprecedented demonstration of international cooperation. The scale of the disaster transcends national boundaries, creating a truly global response that sets new standards for international humanitarian coordination. Consider the technological innovations sparked by the unique challenges of post-impact recovery. Engineers develop new construction techniques designed to withstand both seismic activity and potential future impacts, while materials scientists work with samples of exotic matter from 3I Atlas to understand how interstellar materials might be incorporated into human technology. The disaster forces rapid advancement in fields ranging from atmospheric chemistry to electromagnetic shielding as humanity adapts to a new understanding of cosmic threats. Drift deeper into the stories of individual resilience as survivors rebuild their lives in the transformed landscape. Families separated by the disaster develop new communication methods that work despite ongoing electromagnetic interference. Communities that lost their homes band together to create new settlements designed around principles of sustainability and cosmic awareness that would have seemed fantastical before the impact. The economic recovery demonstrates humanity's remarkable ability to adapt financial and commercial systems to unprecedented circumstances. With Manhattan's financial district vaporized, global markets initially crash, but then reorganize around distributed centers that prove more resilient than the previous concentrated system. The rebuilding effort creates new industries focused on cosmic defense, atmospheric management, and disaster-resistant infrastructure. Picture the educational transformation as schools worldwide incorporate lessons learned from the 3I Atlas impact into their curricula. Children learn not just traditional subjects, but also cosmic awareness, emergency preparedness, and the physics of interstellar objects. The disaster has made cosmic science personally relevant to every student, creating a generation with unprecedented awareness of humanity's place in the universe. The medical community rises to meet unprecedented challenges as healthcare workers treat injuries and conditions never before seen in human medicine. The exotic chemistry released by 3I Atlas creates new types of exposure that require innovative treatment approaches. Medical schools develop new specializations in cosmic disaster medicine, while researchers work to understand the long-term health effects of exposure to interstellar materials. Consider the psychological healing process as communities work through the collective trauma of witnessing cosmic destruction. Mental health professionals develop new therapeutic approaches for processing experiences that challenge fundamental assumptions about safety and permanence. Support groups form around shared experiences of cosmic survival, creating new forms of community bonding based on mutual understanding of ultimate vulnerability. The religious and philosophical response demonstrates humanity's capacity to find meaning in even the most devastating circumstances. Some faith communities interpret the impact as a call to better stewardship of Earth, while others see it as motivation to develop space-based civilizations less vulnerable to cosmic accidents. New spiritual movements emerge that incorporate cosmic awareness into traditional beliefs, creating frameworks for understanding humanity's relationship with the broader universe. Urban planning evolves dramatically as architects and city planners design New Manhattan, a new city built where the crater has been filled and stabilized. This new urban center incorporates lessons learned from the disaster, with distributed infrastructure systems, underground shelters designed to withstand cosmic impacts, and architectural styles that celebrate both human achievement and cosmic humility. The city becomes a model for cosmic-aware urban design that influences city planning worldwide. Picture the agricultural innovations developed in response to the changed environmental conditions. Farmers develop new crop varieties adapted to altered light conditions and atmospheric chemistry, while agricultural engineers create greenhouse systems that can maintain Earth-normal growing conditions even under continued atmospheric dust loading. The food system becomes more resilient and distributed, reducing vulnerability to future cosmic events. The scientific community experiences perhaps the greatest transformation, as the impact provides unprecedented opportunities to study materials and processes from beyond our solar system. Laboratories worldwide analyze samples of 3I Atlas debris, leading to advances in materials, science, chemistry, and physics that accelerate human technological development by decades. The disaster becomes a catalyst for scientific advancement that benefits all humanity. International cooperation reaches new levels as governments recognize that cosmic threats require planetary-scale responses. The United Nations establishes a Cosmic Defense Coordination Office with resources and authority that transcend traditional national sovereignty. Early warning systems for detecting potentially hazardous interstellar objects become as important to national security as traditional military defense systems. Consider the cultural renaissance that emerges from the disaster as artists, writers, and musicians process the experience of cosmic collision through creative expression. New art forms develop that capture the unique aesthetic of post-impact landscapes, while literature explores themes of cosmic vulnerability and human resilience. The disaster inspires creative works that help humanity process and learn from the experience. The insurance and financial industries adapt to the new reality of cosmic risk by developing new types of coverage and investment strategies. Cosmic impact insurance becomes a standard part of homeowners' policies, while investment funds focus on technologies and infrastructure designed to withstand or prevent future impacts. The economic system evolves to price cosmic risk appropriately while encouraging development of protective technologies. Environmental restoration becomes a new scientific discipline as teams work to rehabilitate ecosystems affected by exotic chemistry and altered atmospheric conditions. Biologists develop new techniques for helping terrestrial species adapt to chemical environments that include compounds from interstellar space. The disaster drives innovations in ecological management that prove valuable for addressing other environmental challenges. As the 5th anniversary of the impact approaches, humanity has not simply recovered from the disaster, but has transformed it into an opportunity for growth and development. The crater where Manhattan once stood has become a memorial park surrounding a research center dedicated to cosmic defense, while the rebuilt city demonstrates humanity's capacity to learn from catastrophe and build something better. The recovery demonstrates that while cosmic forces can destroy cities and disrupt civilizations, they cannot eliminate the human spirit's capacity to adapt, innovate, and find hope, even in the face of ultimate cosmic uncertainty. But perhaps the most profound transformation lies not in the physical reconstruction, but in humanity's evolved understanding of our cosmic citizenship. In the transformed world that emerges from humanity's encounter with 3I Atlas, imagine the profound shift in cosmic consciousness as our species evolves from a planet-bound civilization occasionally gazing at the stars to a truly spacefaring society acutely aware of both the wonders and dangers that drift through the cosmic ocean around our small world. The impact has fundamentally altered not just the geography of Manhattan, but humanity's entire relationship with space, danger, and our responsibility as cosmic citizens. Picture the massive technological mobilization that begins in the months following the impact as nations worldwide commit unprecedented resources to developing planetary defense systems. The stark reality that a single object from interstellar space could eliminate one of Earth's greatest cities in minutes forces a complete reevaluation of defense priorities. Military budgets previously focused on terrestrial conflicts now allocate substantial resources to cosmic threats, creating entirely new branches of armed forces dedicated to protecting Earth from space-based dangers. Consider the network of detection systems now under construction across the globe and throughout the solar system. Advanced telescopes equipped with artificial intelligence scanning software monitor the skies continuously for objects following trajectories similar to 3I Atlas. These systems represent a quantum leap in astronomical observation, capable of detecting potentially hazardous objects years or even decades before they might threaten Earth. The early warning network extends beyond Earth orbit, with robotic sentinels positioned throughout the solar system to provide maximum advance notice of approaching interstellar visitors. The development of deflection technologies takes on urgent priority as engineers work to create systems capable of altering the trajectory of objects traveling at interstellar velocities. Traditional asteroid deflection methods, gravity tractors, kinetic impactors, nuclear pulse systems prove inadequate for objects moving at 58 kilometers per second. New propulsion technologies emerge from this challenge, including fusion-powered interceptors and exotic matter manipulation systems that would have seemed like science fiction before humanity's encounter with 3I Atlas. Drift deeper into the philosophical transformation as humanity grapples with the implications of living in a universe where cosmic catastrophe can arrive without warning from the depths of interstellar space. Religious and secular philosophers alike struggle to incorporate this new cosmic awareness into frameworks for understanding human purpose and meaning. Some interpret the impact as a wake-up call to develop spacefaring capabilities that would ensure human civilization survival beyond Earth, while others see it as motivation to better appreciate and protect our planetary home. Picture the educational revolution as cosmic awareness becomes integrated into every level of human learning. Elementary schools teach basic astronomy alongside reading and mathematics, while universities develop entire departments dedicated to cosmic defense studies. Children grow up with an intuitive understanding of humanity's place in the galaxy that previous generations lacked, creating a population naturally oriented toward space exploration and cosmic protection. The space program experiences unprecedented expansion as governments and private organizations recognize that humanity's long-term survival requires the ability to detect, study, and potentially redirect cosmic threats. Moon bases transition from scientific outposts to essential components of Earth's defense infrastructure, while Mars colonies shift from aspirational goals to practical necessities for ensuring civilizational continuity. The impact has made space exploration not just scientifically interesting, but existentially crucial. Consider the international cooperation that emerges from recognition that cosmic threats transcend national boundaries. The Planetary Defense Consortium becomes humanity's first truly global military organization, with resources and authority that supersede traditional national sovereignty when dealing with cosmic threats. Nations that previously competed for terrestrial resources now collaborate on projects that protect all human civilization from the dangers lurking in interstellar space. The economic implications of cosmic awareness create entirely new industries while transforming existing ones. Insurance companies develop sophisticated models for pricing cosmic risk, while construction firms specialize in impact-resistant architecture designed to survive various levels of cosmic collision. The space economy expands exponentially as cosmic defense drives demand for launch services, space-based manufacturing, and orbital infrastructure. Picture the scientific renaissance sparked by analysis of 3I Atlas debris and the new understanding of interstellar chemistry it provides. Laboratories worldwide study samples of exotic matter from beyond our solar system, leading to breakthroughs in materials science, physics, and chemistry that accelerate technological development across multiple fields. The disaster becomes a catalyst for scientific advancement that pushes human knowledge and capability forward by decades. The cultural impact manifests in art, literature, and entertainment that reflects humanity's new cosmic consciousness. Movies and novels explore themes of cosmic vulnerability and planetary defense, while artists create works that capture both the terror and beauty of cosmic forces. A new aesthetic emerges that celebrates both human achievement and cosmic humility, recognizing our species' remarkable capabilities alongside our fundamental vulnerability to forces beyond our control. Environmental science evolves to incorporate cosmic factors into Earth system models. Climate scientists now account for potential impacts of cosmic dust, exotic chemistry, and electromagnetic effects in their long-term projections. Ecological restoration projects consider how terrestrial ecosystems might adapt to periodic disruption from cosmic events, developing resilience strategies that prepare Earth's biosphere for an uncertain cosmic future. Consider the psychological evolution of human civilization as we adapt to living with cosmic awareness. Mental health professionals develop new approaches for helping people process existential anxiety about cosmic threats while maintaining motivation for long-term planning and achievement. Societies learn to balance cosmic humility with human ambition, creating cultures that are both realistic about cosmic dangers and optimistic about human potential. The legal system grapples with unprecedented questions about cosmic citizenship and responsibility. International law expands to address questions about who has authority to deflect or destroy potentially hazardous cosmic objects, while property rights extend into space as nations and private organizations establish infrastructure for planetary defense. The impact forces humanity to develop legal frameworks for operating as a spacefaring civilization. Urban planning incorporates cosmic awareness into city design, with underground shelters becoming standard features of new construction, while above-ground architecture emphasizes distributed systems that can maintain function even after partial destruction. The rebuilt Manhattan becomes a model for cosmic resilient urban design that influences city planning worldwide, creating settlements that can survive and recover from various levels of cosmic disruption. As the 10th anniversary of the 3I Atlas impact approaches, humanity has transformed from a species that occasionally wondered about cosmic threats to one that actively monitors, studies, and prepares for the dangers and opportunities that drift through interstellar space. The Crater Memorial Park in New Manhattan has become a pilgrimage site for people worldwide, a place to contemplate both the fragility and resilience of human civilization. The transformation demonstrates that while cosmic forces can destroy cities and disrupt civilizations, they can also catalyze human development in ways that make us stronger, wiser, and better adapted to life in a dynamic and dangerous universe. But perhaps the most profound legacy of 3i Atlas lies not in the technologies or institutions it inspired, but in the deeper questions it raised about humanity's cosmic future. In the gentle years following the cosmic catastrophe, imagine the remarkable phoenix that rises from the ashes of destruction. New Manhattan, a city unlike any in human history, built both as a testament to human resilience and as a living memorial to the millions lost when 3i Atlas transformed one of Earth's greatest urban centers into a smoking crater. This new city represents not just architectural and engineering achievement, but humanity's evolved understanding of how to build civilizations that can survive in a universe filled with cosmic dangers. Picture the careful process of crater stabilization and foundation preparation that precedes any construction. Engineers working with exotic materials created by the impact develop new techniques for creating stable ground from the transformed bedrock. The crater walls, composed of rock metamorphosed by temperatures and pressures beyond terrestrial experience, require specialized engineering approaches that push the boundaries of geological science. The foundation work becomes a masterpiece of technical achievement, creating solid ground where cosmic violence once vaporized the heart of Manhattan. The memorial design at the crater's center reflects humanity's new cosmic consciousness while honoring those lost in the disaster. A crystalline structure built from materials that incorporate actual particles of 3i Atlas rises from the exact point of impact. At night, the memorial glows with bioluminescent elements that create shifting patterns reminiscent of aurora displays, reminding visitors of the cosmic forces that brought both destruction and transformation to this place. Consider the revolutionary architecture of New Manhattan, designed with cosmic awareness integrated into every structure. Buildings incorporate impact-resistant design principles, with flexible frameworks that can absorb tremendous shock while maintaining structural integrity. Underground spaces connect throughout the city, creating a secondary urban level that can maintain essential functions even if surface structures suffer damage. The architecture celebrates human achievement while acknowledging cosmic vulnerability. Drift deeper into the street layout and urban planning that makes New Manhattan a model for cosmic resilient city design. Unlike the rigid grid system of old Manhattan, the new city features curved streets that channel shockwaves around critical infrastructure while creating beautiful organic patterns that complement the memorial at its center. Parks and green spaces are distributed throughout the urban fabric, providing both aesthetic beauty and emergency evacuation areas designed to handle various cosmic emergency scenarios. The transportation system represents a quantum leap in urban mobility, with magnetic levitation trains running through sealed tunnels that can maintain operation even during atmospheric disturbances. The system connects not just within New Manhattan, but extends throughout the rebuilt New York metropolitan area, creating a distributed urban network less vulnerable to single-point failures. Above ground, automated vehicles navigate streets designed to facilitate rapid evacuation while maintaining normal traffic flow. Picture the residential architecture that reflects humanity's new relationship with cosmic forces. Homes feature reinforced shelters that can protect families during various types of cosmic events, while rooftop observatories allow residents to participate in the continuous skywatch that has become part of civic duty. The buildings themselves incorporate materials and design elements inspired by the study of 3i Atlas debris, creating structures that are both beautiful and cosmically aware. The economic district of New Manhattan demonstrates how financial systems can be designed to operate even during cosmic emergencies. Trading floors feature multiple backup systems and distributed computing networks that can maintain market function even if primary systems fail. The architecture itself tells the story of economic resilience, with buildings designed to protect both data and personnel from various types of cosmic interference. Educational institutions throughout New Manhattan serve as models for cosmic-aware learning. Schools feature planetariums and observatories as standard equipment, while curriculum integrates cosmic science into every subject area. Students learn mathematics through orbital mechanics problems, study chemistry by analyzing exotic matter from 3I Atlas, and develop language skills by reading literature inspired by humanity's cosmic awakening. Consider the cultural institutions that emerge from humanity's transformed cosmic consciousness. Museums display artifacts from the original Manhattan, alongside materials created by the cosmic impact, telling the story of transformation and resilience. Theaters present works that explore themes of cosmic vulnerability and human strength, while music venues feature compositions inspired by the sounds of interstellar space and the rhythms of orbital mechanics. The residential neighborhoods reflect communities bonded by shared experience of cosmic catastrophe and collective commitment to cosmic awareness. Neighbors participate together in skywatch programs, emergency preparedness drills, and educational activities that maintain community readiness for future cosmic events. The social fabric of New Manhattan incorporates cosmic citizenship as a fundamental aspect of community life. Religious and spiritual centers throughout the city reflect humanity's evolved understanding of our place in the cosmos. Some denominations interpret cosmic awareness as deepening traditional faith, while others develop entirely new spiritual practices based on cosmic consciousness. The diversity of spiritual response demonstrates humanity's capacity to find meaning and purpose even in the face of ultimate cosmic uncertainty. The Research District houses institutions dedicated to studying cosmic threats and opportunities. Laboratories analyze ongoing samples of 3I Atlas materials, while observatories monitor the skies for signs of future interstellar visitors. The research complex serves both practical planetary defense purposes and pure scientific investigation, ensuring that humanity continues learning from its cosmic encounter. Picture the healing gardens that grow throughout New Manhattan, featuring plant species selected both for their beauty and their ability to thrive in atmospheric conditions affected by exotic chemistry. These green spaces provide both aesthetic enjoyment and practical air filtration, while serving as living laboratories for studying how terrestrial life adapts to cosmic influences. The memorial ceremonies held annually at the impact site bring together survivors, their descendants, and visitors from around the world to remember the lost while celebrating human resilience. These gatherings become festivals of cosmic consciousness, featuring art, music, and storytelling that honor both the tragedy and the transformation that followed. The ceremonies help humanity process collective trauma while maintaining hope for the future. As New Manhattan approaches its 15th anniversary, the city stands as proof that human civilization can not only survive cosmic catastrophe, but can use such experiences to build something better than what existed before. The skyline, rising from ground that was once vaporized by interstellar collision, reaches toward the stars with both humility and determination. The city serves as a beacon for other communities worldwide, demonstrating that cosmic awareness need not create paralyzing fear, but can instead inspire innovation, cooperation, and deeper appreciation for both human achievement and cosmic mystery. But as we reflect on this remarkable transformation, perhaps the most important question concerns what lessons humanity has learned about living consciously in a universe filled with wonders and dangers beyond our imagination. As our gentle exploration of this hypothetical cosmic catastrophe draws toward its peaceful conclusion, settle into contemplation of the profound lessons that humanity might learn from such an encounter with forces from the depths of interstellar space. The transformation of New York City from thriving metropolis to impact crater to rebuilt cosmic-aware city represents more than urban planning and disaster recovery. It embodies humanity's evolution from a planet-bound species to true citizens of the cosmos. Picture the fundamental shift in human perspective that emerges from direct experience with cosmic forces. Before 3I Atlas, space seemed vast and empty, with dangers so remote as to be merely theoretical. After the impact, every human being carries intimate knowledge that we live in a dynamic universe where objects from unimaginable distances can arrive without warning to reshape our world in minutes. This cosmic awareness becomes as fundamental to human consciousness as awareness of weather, changing how we plan, build, and dream. Consider the humility that cosmic catastrophe teaches about human achievement and technological capability. The greatest city ever built by human civilization, with all its architectural marvels and technological sophistication, proved as fragile as a sandcastle when confronted by cosmic forces. Yet this humility doesn't diminish human accomplishment, but rather places it in proper cosmic context. We are remarkable beings capable of extraordinary achievements, but we exist within a universe whose power dwarfs our greatest efforts. Drift deeper into the lessons about international cooperation and shared human destiny that emerge from cosmic threat. National boundaries that seem so important for terrestrial politics prove meaningless when facing objects from interstellar space. The 3I Atlas impact demonstrates that humanity shares a common vulnerability that transcends all artificial divisions, creating practical motivation for cooperation that extends beyond idealistic appeals to human brotherhood. The disaster teaches profound lessons about the relationship between technological advancement and cosmic awareness. Humanity's greatest achievements, cities, transportation networks, communication systems, prove vulnerable to cosmic forces, but the same human ingenuity that created these achievements can adapt them to cosmic realities. The rebuilt New Manhattan demonstrates that cosmic awareness enhances rather than limits human capability, inspiring innovations that make civilization more resilient and sophisticated. Picture the transformed relationship with risk and uncertainty that emerges from cosmic awareness. Traditional approaches to risk management focus on threats we can predict and control, economic fluctuations, weather patterns, geological processes. Cosmic threats introduce fundamentally unpredictable elements that require new approaches to planning and decision-making. Humanity learns to balance long-term thinking with acceptance of cosmic uncertainty, creating adaptive strategies that can respond to unforeseeable circumstances. The impact demonstrates the importance of scientific understanding in preparing for cosmic challenges. The ability to analyze 3I Atlas's composition, trajectory, and behavior provides crucial information for both immediate response and long-term planning. Humanity learns that investment in scientific research and education pays dividends not just in technological advancement, but in civilizational survival. The exotic chemistry and physics revealed by the impact accelerate human knowledge in ways that benefit multiple fields of endeavor. Consider the lessons about community resilience and social cooperation that emerge from shared experience of cosmic catastrophe. Communities that work together to prepare for and respond to cosmic threats prove more resilient than those that rely on individual preparation alone. The disaster teaches that cosmic citizenship requires both personal responsibility and collective action, creating social bonds based on shared vulnerability and mutual dependence. The rebuilding process reveals insights about adaptive architecture and urban planning that apply far beyond cosmic defense. Cities designed to withstand cosmic impacts prove more resilient to earthquakes, severe weather, and other terrestrial disasters as well. The principles of distributed infrastructure, flexible design, and community integration that characterize New Manhattan provide models for sustainable urban development that benefits human civilization regardless of cosmic threats. The experience teaches valuable lessons about psychological resilience and meaning-making in the face of ultimate uncertainty. Humans prove remarkably capable of adapting to cosmic awareness without losing hope, creativity, or ambition. The disaster demonstrates that awareness of cosmic dangers can inspire rather than paralyze, motivating achievements that might never have emerged without recognition of our cosmic vulnerability. Picture the educational transformation that follows from integrating cosmic awareness into human learning. Students who grow up understanding orbital mechanics, atmospheric physics, and interstellar chemistry develop intuitive appreciation for cosmic forces that previous generations lacked. This education creates citizens naturally prepared for life in a spacefaring civilization, equipped with knowledge and perspectives that enable continued human expansion beyond Earth. The impact teaches crucial lessons about environmental stewardship and planetary protection. Recognition that Earth exists in a cosmic environment filled with potential threats adds urgency to protecting our planetary home while developing capabilities for human expansion beyond it. Environmental protection becomes not just moral imperative, but practical necessity for maintaining the conditions that enable human civilization to thrive and develop cosmic defense capabilities. The disaster reveals insights about economic adaptation and resource allocation in the face of cosmic threats. Traditional economic models focused on terrestrial resources and markets prove inadequate for addressing cosmic challenges. New economic frameworks emerge that account for cosmic risks while encouraging innovation in planetary defense and space development. The rebuilding creates industries and economic opportunities that demonstrate how cosmic challenges can drive beneficial economic development. Consider the lessons about cultural and artistic expression that emerge from cosmic encounters. Human creativity proves remarkably capable of processing and expressing cosmic experiences, creating new forms of art and culture that help communities understand and adapt to cosmic realities. The cultural renaissance that follows the impact demonstrates that human meaning-making can incorporate even the most challenging cosmic experiences into frameworks for continued growth and development. As we reach the conclusion of this cosmic meditation, the most profound lesson may be about human adaptability and hope. Despite experiencing one of the most devastating events in human history, civilization proves capable not just of survival, but of transformation that incorporates cosmic catastrophe into the foundation for even greater achievement. The rebuilt New Manhattan, rising from ground once vaporized by interstellar collision, stands as testament to humanity's remarkable capacity for learning, growing, and thriving, even under the most challenging cosmic circumstances. The legacy of 3I Atlas becomes not just the crater it created or the city rebuilt from cosmic ashes, but the transformation of human consciousness from planetary to cosmic awareness. A gift from the depths of interstellar space that prepares our species for whatever wonders and challenges await in the vast cosmic ocean that surrounds our small, precious world. In the peaceful silence that follows our journey through this cosmic catastrophe and human resilience, imagine looking up at the night sky from the rebuilt New Manhattan, where the memorial crystal glows softly at the city's heart. A reminder of both humanity's vulnerability to cosmic forces and our remarkable capacity to transform even the greatest disasters into opportunities for growth, learning, and deeper cosmic awareness. The hypothetical impact of 3I Atlas on New York City serves as more than a thought experiment about cosmic destruction. It illuminates the profound truth that we live in a dynamic universe where objects from unimaginable distances carry within them the power to reshape worlds and transform civilizations. Yet it also demonstrates that human resilience, creativity, and cooperation can meet even cosmic challenges with hope and determination. As you drift toward sleep tonight, carry with you the gentle knowledge that while cosmic forces beyond our control drift through the darkness between stars, humanity possesses the wisdom, ingenuity, and spirit to face whatever the universe may offer. Whether wonder, danger, or the unexpected combination of both that drives our species toward ever greater cosmic awareness and capability. Sweet dreams, and may your rest be filled with visions of cities rebuilt from cosmic ashes, rising toward the stars with both humility and hope. If this exploration of cosmic catastrophe and human resilience has sparked your curiosity about our place in the universe, please consider subscribing to our channel and sharing this journey with others who find wonder in contemplating humanity's cosmic future. Your support helps us continue creating these peaceful explorations of space science and cosmic consciousness, bringing you thoughtful examinations of how cosmic forces shape human civilization and destiny. Until our next voyage through the cosmos, sleep well.